Hey everyone, welcome back. I hope you're all doing well. In this video, we're going to learn about resource allocation and leveling, which are crucial techniques for managing construction project resources. In this lesson, we will focus on key aspects of resource management in construction projects. First, we'll explore the common types of resources, including labor, equipment, and materials. Next, we'll learn how to develop a resource usage diagram to visualize resource allocation over time. We will also discuss strategies for reallocating resources to prevent overallocation, ensuring a balanced workload. Finally, we'll introduce the concept of resource leveling, a technique used to optimize resource distribution and maintain efficiency throughout the project. This video will cover the first two learning objectives, types of resources, and developing a resource usage diagram, while the remaining topics will be discussed in next videos. In construction, resources are essential for completing a project on time and within budget. Typical resources include workers, equipment, and materials, all of which must be carefully managed. Workers include skilled tradespeople such as electricians, carpenters, and masons, as well as general laborers who assist with various tasks. Equipment ranges from heavy machinery like cranes and excavators to smaller tools such as drills and concrete mixers, all of which need to be available and properly maintained. Materials include essential building supplies like concrete, steel, lumber, and drywall, which must be delivered on time to keep the project moving. So, why do we care about resources? Remember, proper resource allocation is crucial because a lack of resources can slow down progress, preventing tasks from being completed efficiently. On the other hand, overallocation, assigning too many resources to a task, can reduce efficiency, leading to wasted effort and higher costs. If too many workers are scheduled for a small task, they may end up standing around with little to do, leading to wasted labor costs. Similarly, bringing in more heavy equipment than necessary can crowd the site, making movement difficult and reducing productivity. Lastly, underutilization of resources occurs when workers, equipment, or materials are not fully utilized, also leading to inefficiencies and increased costs. It can result in idle labor, wasted equipment, and scheduling delays, ultimately slowing project progress. So, balancing resources effectively through techniques like allocation and leveling is crucial for optimizing task sequencing, ensuring smooth project execution, and maximizing productivity. To manage resources effectively, the resource usage diagram is a great tool. Now, let's talk about the resource usage diagram and how it helps in managing construction resources. The first step in this process is to develop a resource-loaded bar chart. This starts with creating an early start bar chart, which schedules activities to begin as early as possible based on project constraints. Next, resources such as workers, equipment, and materials are assigned to each activity, giving a clear picture of what is needed at every stage of the project. Once the resource-loaded bar chart is ready, the next step is to develop the resource usage diagram. This diagram visually represents the demand for resources over time, helping project managers identify peak usage periods and potential shortages. By analyzing the resource usage diagram, managers can make informed decisions about resource allocation, preventing bottlenecks, and ensuring a steady workflow throughout the project. Now, let's go through an example. Given the precedence diagram below, our task is to develop a resource usage diagram. The network consists of 6 activities, labeled A to F. As you can see, the forward pass and backward pass have already been calculated, allowing us to determine the early and late start and finish times for each activity in the network. Additionally, the number of workers, denoted as R, required for each activity, is provided at the bottom of each activity box. To solve this problem, we can follow the steps mentioned earlier. In step 1a, we develop an early start schedule using the early times given in the network. Before drawing the bars, we first need to identify the critical activities. Critical activities are those with the same early and late start times, indicating 0 total float. Any delay in these tasks will directly affect the project's completion time. In this case, activities A, B, D, and F are critical, and we will highlight them in red. Non-critical activities, C and E, which have some scheduling flexibility, will be shown in blue. If you're unsure about how to find critical activities, feel free to refer back to a previous video for clarification. Now, we begin by placing each activity on the timeline according to its early start and early finish times. Since time is measured in days, we'll map each activity to a daily timeline accordingly. First, we plot activity A, which starts at day 0 and finishes at day 1. Since A is a critical activity, we represent it in red. Next, activity B starts immediately after A from day 1 to day 6 and is also critical, so we continue using red. At the same time, activity C starts at day 1 and finishes at day 4. Since C is not critical, we indicate it in blue. For a non-critical activity, be sure to extend it using a dashed line until the late finish date to visualize its float. Then, activity E starts at day 4 and ends at day 7, also in blue as it is a non-critical activity. Like activity C, you extend E using a dashed line to its late finish at 11. Meanwhile, activity D follows B, running from day 6 to day 11. Because it's critical, we highlight it in red. Finally, activity F starts at day 11 and finishes at day 12, marking the project's completion. Since it is also critical, we keep it in red. This early start bar chart offers a clear visual representation of activity sequencing, where each task begins as early as possible. The use of different colors helps us easily distinguish between critical and non-critical activities, as well as assess their scheduling flexibility. The next step, Step 1b, involves developing a resource-loaded schedule, which integrates resource information into the bar chart schedule. To do this, we first need to find the resources assigned to each activity. As given in the network, the number of workers, R, required is summarized as follows. For example, activity A needs 1 worker, 1 R, and activity B needs 3 workers, 3 R. To develop the resource-loaded schedule, we simply place the resource information above each corresponding bar, like this. In the last step, we need to create the resource usage diagram. We plot the total number of workers required on each day. For example, on day 1, only activity A is happening, requiring 1 worker. On day 2, both activities A and B are running, so the total number of workers required that day is 7. As we continue, we sum up the workers needed for each day based on the activities in progress. Plotting this data results in a diagram that shows a clear visual representation of how the resource usage fluctuates over time, allowing us to see when resources are over or underutilized, helping in resource management and potential adjustments. By examining the resource usage diagram, we can see that the resource demand throughout the project is highly unstable. On some days, the workforce requirement is minimal, while on others, there's a sudden surge in demand. For example, on day 1, only 1 worker is needed, and after day 7, the requirement drops to just 2 workers per day. However, during the period from day 2 to day 7, there's a significant spike in resource demand, ranging from 7 to 8 workers. This fluctuation can create several potential issues. Sudden increases in resource demand may lead to labor shortages, requiring rapid mobilization of additional workers, which can be costly and inefficient. On the other hand, periods of low demand may result in underutilization of resources, leading to idle time, waiting for new tasks, and ultimately reduced productivity. Such instability in resource usage can complicate workforce planning, increase costs, and even cause scheduling conflicts. Addressing these variations through resource allocation and leveling can help create a more balanced and efficient resource allocation strategy. All right, that's it for this video, where we covered key concepts related to construction resources, why we care about them, and the method to develop a resource usage diagram. Thanks for watching, and we'll see you in the next video. Goodbye.